Good morning, everyone, and thank you for being in class. And we are going to start 3.2. If you are having trouble with any problems from 3.1, feel free to email me and tell me which ones you need help with. I'll be happy to record it and incorporate it into our next lesson. If I get an email from you today, I will try to make sure I add it to my lesson tomorrow. So the plan is to do 3.2. I know you can probably see my solution manual, but we're more interested in these. Now, the good news about 3.2 is we don't have to do a lot of extra lecturing here. You can just jump right into the problems, and you're going to see 3.2 is just a tad bit beyond 3.1. And they could have easily put all these problems in the same section. They could have. Now let's try them. It's the same concept, inverse function. Okay. Now they are going to mix it up. All right. We kind of know what cosecant and secant are, and we're going to tell you in which areas we want to find our solution. So let's start. Let's start. And I will try to double check my answers because I do make mistakes at times. And I'm not saying that's a good thing, but let me see. I'll go to our page. Okay, give me 1 second. All right, guys. So here we are. And just one more thing. I'm working on your study guide for the next exam. It's going to be here. I wrote 3.1, 3.2, 3.2, etc. Hopefully, we'll stop at 3.3, 3.4. I don't know. Don't worry too much about it. I hope you guys can see my screen. Let's get right into it. So 3.2. And let me see if I can find a slide that'll save us a little bit of time. Okay, so bear with me. Bear with me a little bit. I'm looking for a formula for you guys, okay? I want to write it. All right, this is the one I've been looking for. Okay, good. I'm glad I found it. This is the one. Wonderful. So guys, when we discussed it, okay? When we find inverse functions, we want our theta value to be, I call it sometimes the right half, okay? For sine, tangent, cosecant, it's the right half. For cosine, secant, and cotangent, it's the upper half. Now, you can say upper half, you can say the first quadrant and the second quadrant. You can say the right half, you can say the first quadrant or the fourth quadrant. Now, a little bit of background, okay? Well, why do we do that? Well, the other half will repeat. We want a unique answer. And the mathematicians have decided that they will look for the unique answers right in these areas for sine, cosecant, and tangent, and in these two areas for cosine, secant, and cotangent. Kind of makes sense, actually. And this area, sometimes we write it like this, and you have seen me write that. I'm going to write it again. We will sometimes say it like this. So it's negative pi over 2 to positive pi over 2. And this one, the other one, is going to be 0 through pi. Okay. So now For tomorrow, what I'm going to do, well, for future, I'm going to take this picture and save it. So give me 1 second. I will use this. Then I don't have to redo it every day. The left-hand side is this. This is the version sometimes we use, and I've used that in the past. But I like the visual version a little better because to me, it's more vivid. Makes more sense. But we should know both. They're really the same. Some people say it like this. Some people will say it like this. Some people say it like this. Some people will say it like this. So let me save this, okay? So bear with me. All right. Now, getting back to our problem. All right. So now I'm going to get rid of this. So we have a lot going on here, okay? We're going to combine the two. That's why this picture will help me a lot. Because we're going to combine sine and cosine when we want to have everything in front of us so that when we refer to it, we know exactly what we are talking about. And I know I'm doing it a little slowly today, kind of on purpose, guys. I just don't want to rush through so that we have everything on the same page. All right, let me rename it. Okay, good. Now let's take this guy and solve some problems using this slide. All right, we're going to go back and forth, back and forth. So be a little patient. I hope it's not too small. If I write too small, if a picture is too small, mute yourself and tell me. I will enlarge it. It's nothing, right? All right, so guys, we are in 3.2. We are not doing a long lecture. There's not a whole lot to go over. Let's do some problems, okay? These are the ones that will prepare you to work on the problems from 3.2 on MATLAB. I'm going to do 33, okay? And I'm going to do it step by step. Now you're going to see you can't even cancel, okay? You can't cancel cosine and sine inverse. So all the cancel shortcut we did, it's nice to know sometimes you can cancel, but most of the time you'll have to do it the hard way. All right. And I'm going to throw away my tea bag and I'll be right back, guys. It'll take me like 10 seconds. All right, I'm back. So as before, whatever the inverse part is, I'm going to define it as theta. Okay. You don't like theta, you don't like to pronounce it, you can call it y. Nobody cares. And I'll do it very carefully. All right, I'm going to say this guy is theta. All right, sure, no problem. Now, if this guy is theta, the top now becomes, what does it become? It becomes cosine theta, right? Now, somehow, magically and correctly, if you can find the value of cosine theta, you're good, you're done. Okay, guys, that's the key. Once you take a complicated thing and give it a nice simple name, and you do the math, you do the correct math, you have the answer. Now, based on the definition of sine inverse this, let's bring our favorite guest, which is our unit circle. I don't know how well you can see. Of course, I'll make it a little bigger. I can. I'm going to slide it on top and make it bigger. And I do need the room. So guys, from this, remember sine theta, you look for it in the right half. For what angle theta would the sine value be square root of 2 over 2? Sine is the y coordinate. I'm going to go by pi over 4. Okay. I can say this. I can say this means sine theta is equal to square root of 2 over 2. Go back to a unit circle. Okay, for what angle theta, the sine value is going to be square root of 2 over 2. It's clearly this guy. Now, I know problems are getting a little difficult, so this time I'm going to use a little more pictures right here. So clearly theta is 45. Done. Not well, not done. Um, we have made some progress. So theta is 45. And this is nothing new. This is something we did last class. And I can write 45 degree, but so far we have been using pi. I'm just going to write pi over 4. Okay. Now, you're not done, but if you could find the value of cosine theta where theta is pi over 4, you would be done, isn't it? Now, that's not too difficult. I'm going to go back to this guy. I'm going to say, okay, now that I know what theta is, I can write cosine pi over 4 because that's what theta is. I just found it. What's cosine pi over 4? Come back to your old friend, unit circle. Cosine pi over 4 is square root of 2 over 2. You might say, I could have canceled it. Well, trust me, it's not going to work every time you cancel. It happens to cancel this time, all right? So don't just randomly cancel. It only works for cosine and sine when you have pi over 4. So I'm going to check my answer and I'll be happy to take some questions, guys, okay? So once again, let me first check my answer. It's 33, 3.2. Let me see. Yes, we got it right. So good. That's not a bad sense. So I'll be happy to take questions, guys. I'll give you a couple of minutes to process it. Okay. So it seems like we're canceling. We're really not. And this won't cancel, and the answer won't be this all the time. It's a unique case where it happens to be that. By the way, guys, when I record videos for other students, I just record, right? I don't pause, but I know where I have people, we have people here, so I try to pause with you guys, okay? So, and it takes a little bit of time to process. You can, of course, take a picture of my screen anytime you want. So those things are fine. And you can, of course, watch the video too. But I'm going to move on unless you have questions for me, guys. All right, let's do one. Let's do a different one. Okay, let's do something like this. Cotangent, sine inverse. Let's do 38. Let's do 38. Let's see what's going on with 38. All right, I'm going to save some of these guys here because we will be needing them. All right, same kind of a deal. All right, there's no question of canceling anything here. Okay, cotangent and sine, I don't know what's going on. So I'm going to call this mess inside theta. So sine inverse 1 negative half will be defined as theta. That will make my question cotangent theta. Okay, simple enough. If I know what theta is, I have to find cotangent of theta. I'll be in good shape. Now, again, we're talking about sine. We are talking about the answer being in the answer being in the right half of the unit circle only. All right. So sine negative half, look, sine is the y coordinate. Look for negative half, nope. Look for negative half, nope. Negative half, nope. Negative half. Now you can do this. I can actually do it without the unit circle. Okay, just to let you know, I know you guys have open book exams, so most of you will have your unit circle in front of you. I'm doing it that way. I really know how to do it without the unit circle. I haven't memorized the unit circle, but I can figure it out. And it's not a bad thing to do, but we'll move on. So guys, I'm going to say theta has to be, now, let's explain this. Theta, you can call it 330, but people don't like 330, okay? They would rather say this is minus 30, negative 30, okay? I'm going to say theta is, you can say negative 30, you can say negative pi over 6. I'm just going to say negative pi over 6, okay? Let me see what's going on. Let me hide this. If I'm not mistaken, yeah, that's going to be negative pi over 6. So I'm going to say this means from the unit circle. Now you can write down one more step, and it's not a bad habit. It's not a bad habit. This means theta is negative pi over 6. Okay, why am I emphasizing this? There are a few things good about taking an online class, and there are a few things that are bad. For instance, on the exam, if you wrote 330, positive 330, or positive 11 pi over 6, I would be okay. But I think your book expects you to do it the way I'm kind of doing it. So now you go back, you know what theta is, you go back and you say, okay, and don't forget the minus. No big deal. All right, we can find it. And we have done this in one of the sections. So basically, all you're doing, guys, is finding the cotangent value for this point. Remember, cotangent theta is cosine over sine. Cosine is square root of 3 over 2. Sine is negative half. And I will do it here. I will do it here. I'll be happy to do it here. I'll show you the details. So what's the sine value? What's the cosine value? Negative half. And what's the sine value? Square root of 3 over 2. And I put the negative outside, not a bad choice. Okay, not a bad choice. You can certainly do it. And now, guys, I have two denominators that are the same. I can simply cancel them. You can flip and multiply, doesn't matter. This is the answer I'm getting, guys. This is the answer I'm getting. And this is kind of, you can call it the, I wouldn't say scratch work. This is the first part of the problem. Okay, right here. And this is the second part of the problem. And we have everything. I will, let me go ahead and check my answer. Then I will come back to the screen and leave it here for at least a minute. Okay. Number 38. Oh boy, what did I do? Okay, let me double check. Cotangent. Um, Cotangent is, sorry guys, cotangent is cosine over sine, guys. I made a stupid mistake. Let's fix it. Cotangent, I wrote, I flipped it. Okay, so this is this over. All right, now I cancel the bottom twos and my answer will be this. I'm sorry about that, guys. Fixed. And why do we have minus? Because one is plus, one is minus. Let me check the answer again. 38. That's much better. So what I did, don't make this mistake. So what I did, cotangent is cosine over sine. I did tell you cosine over sine, but I wrote sine over cosine. My bad, my apologies. Now we have the right one, corrected problem. Go take a look. Tell me if you need me to repeat something. All right, guys, we're going to do one more. I'm going to get rid of these. All right. You can always pick a problem. You can always do this, do that, always. Let's try 46. It looks difficult enough, right? Cotangent, tangent. Cotangent, tangent problems are always a little more complicated because they're not directly coming out of your unit circle. That's what makes them slightly different, difficult. All right, so like before, okay, guys, here I have to call this whole thing, this whole mess, theta, okay? It's how we do it. All right, this whole thing is theta. And remember, guys, we're talking about tangent. Tangent is buddy-buddy with sine here. So our answer has to be on the right half, okay? I'm just going to say the right half. So this slide tells you that, okay? I'm going to say this whole mess is theta, and theta must be in the right half. I'm going to go back. I need the room. I don't know where I'm going to put this pink dot, but I'm going to save it here. All right, so let's do it. I'm going to take the time to enter the whole thing as accurately as possible. I'm going to say this is theta. If this is theta, I can certainly write tan theta by definition of inverse function. I can certainly write this perfectly legitimate step based on the very basic definition of inverse function. And be a little patient with me. I'll fix it. Well, I'm going to let this guy go, and I just have to redo my box. So tan theta is equal to cotangent 2 pi over 3. All right. Now, remember, guys, theta must be on the right-hand side. Okay. Now, you're going to find the value of cotangent 2 pi over theta. Okay. I'll do it very carefully. Cotangent, I need to know the value of this from the unit circle, which is not difficult if we don't make a mistake, right? If I don't make a mistake, 2 pi over 3. Remember, this is pi over 3. This is 2 pi over 3. Okay. So far, we are here. All right. Again, cosine over sine. If you do cosine over sine, this over this, you're going to get negative 1 over square root of 3. Okay. This value from the unit circle turns out to be, and I'm going to double check just to make sure I didn't make a mistake. If you divide 1/2 minus 1/2, cosine over sine, you're going to get negative 1 over square root of 3. Negative 1 over square root of 3. Okay, so far so good, but you need to know, you're calling this whole mess theta, you need to know the value of theta. You do know tan theta is this, and theta is in this half, is in the right half. So here, hunt down which angle gives you this for the tan, what value of theta on the right hand side gives you tan theta, or turns out, or makes tan theta to be negative 1 over half. So on this side, it's going to be either this or this or this or this. Now, since I have a negative sign, I'm either going to consider this or this. So there aren't too many options. Once again, on the right-hand side, I'm asking for what angle theta would tan theta be negative 1 over square root of 3. Again, tan is sine over cosine. So I'm going to say it has to be this one. Look, negative half, which is sine, over cosine, which is square root of 3 over 2. And if you cancel the 2's, you'll get negative 1 over square root of 3. So that allows me to conclude the answer is, what value of theta will do that? What is tan theta? And that's what you're looking for. You're going to say, hopefully, theta is negative pi over 6. Right here, that's your answer. Now let me go back and check the answer. Make sure I didn't mess up. 46. Yeah, we got it right. Okay, negative pi over 6. So it's the same story, same story. Now I'm going to come back and we'll do 2 or 3 more problems. Okay, guys, but I'll pause here a little bit. See if you have any questions. If you want me to explain something again, it's not a bad time to pause because we're going to switch soon. All right, guys, I have the slide. You can let's join again. I will do a few more problems from the same section. By the end of today's lecture, you should be able to solve all the problems from 3.2. I'll come back real quick, guys. See you guys soon.